This is the homework helper for Chapter 11, Section 1 in the 8th grade workbook, Simplifying Algebraic Expressions. So in the top part here, the directions are all very similar. We're just combining like terms. So we're taking things that are like, have the same variable to the same power, and just putting them together. So as we look at what we have here in number 1, those are already like terms, so this is really just about simplifying. They're like terms because they both have a cubed in them. So I'm going to take 8a cubed and subtract 5a cubed. I'm going to do exactly what it says. And as I take and subtract those, I end up with 3a cubes. And that whole top row is much similar to that. The only one that's a little bit different is number 3, in that the 6 will stay separate, but you'll combine the a terms and still simplify the expression. All right, if we take a look at number 4, we've got 6x plus 3y plus 5x. Well, of course, as you know, 6x and 5x are the like terms. Why? Because they both have x in them. So since they both have x in them, we can combine those. So the 6x and the 5x are going to go together to make 11x's, and the 3y is going to stay separate, so it's going to say 11x plus 3y, and that's all we can do. We can't put 11x and 3y together because they're not like terms. They'd either both have to be just plain old x or both be plain old y to combine them. As we take a look at number 7, we've got 3k plus 7k plus 5k squared. Now, even though all these have k in them, the first couple just have k, and the last one is k squared. Well, you can't do anything with the k's and the k squareds. Those cannot mix because it has to be the same variable and to the same power. What we can do is put the 3k and the 7k together. So as I put the 3k and the 7k together, that's going to go together to make 10k's. And I'm going to add that to this 5k squared that's at the end, and that will be my simplified expression. 10k plus 5k squared, or if you want to write it the other way, 5k squared plus 10k. As you can see, the expressions are getting a little bit longer here as we go down, but it doesn't really change what we're doing here. In number 10, we've got 4f plus 6 plus 7f minus 2. So we're going to go ahead and combine the f terms and combine the constants here and simplify all we can. So we've got the 4f and the 7f. Those are like terms because they both have f in them. So we can combine the 4f and the 7f. That's going to go together to make 11f. And then I've got the 6 and the 2, which I'm going to go ahead and combine. And when I put the 6 and the 2 here, because it says minus in front of the 2, that's exactly what I'm going to do. I'm going to subtract that 2, and I've got 6 minus 2, and that's going to go together to make 4. So we end up with 11f plus 4. As we go down to the bottom here, we're continuing to simplify, but they're adding some other things here. And so there, with the 4 times the x plus 3 minus the 5, here, because this is the number in front of parentheses, that's distributive. So you're going to carry the 4 through to the x and the 4 through to the 3. 4 through the x is 4x. 4 through to the 3 is 12. So that's going to give me 4x plus 12, and then minus the 5. And then we'll keep on going because we can keep on simplifying here. The 12 and the 5 are both integers, so we can put those together. Those are like terms of their own. 4x will not go with those because it can only match something else that has x. The 12 minus 5 is going to go together to make 7. So we've got 4x plus 7. Now in 16, this continues to be about simplifying expressions here, but this one they're actually asking us to solve. In the front there, as you can see, we've got 6y plus 2y. Those, of course, go together to make 8y's. So we've got 8y equals 16. Solve the equation. You know what to do. You already know the answer. You know the answer is 2 because I'm going to tell you to divide across by 8. And when I do that, y ends up equaling 2.